Okay, with the polynomial questions where we've got to use the remainder theorem and so on, we're better off, first of all, number 6 here, so we're going to call the function, say, f of x, okay? And in part A, it says show that x plus 2 is a factor of the polynomial, okay? So the remainder theorem states that essentially if you've got x minus a as a factor, okay, then f of a would equal to 0. Okay, that's the remainder theorem. So in this case, x plus 2 is a factor. So that implies then that f of, well, let's be careful here, it's actually going to be minus 2, isn't it? Okay, because that's sort of the general theorem when it's x minus a. So you've got the sort of opposite in there then, yeah? Because we've got a minus of a here, that becomes positive a. If it's positive 2 in here, then you do the opposite, minus 2 will equal 0. So what we'll do is we'll put minus 2 in here, okay, and hopefully it'll come out to be 0. So we've got So we use our calculator, okay. So this is the type of question where you don't need to work out each term because it's a calculator paper. As soon as you've got this workings out here, you've written this down, the examiner can see what you're doing, and we've shown then it's equal to 0 on our calculator. Okay, so because it's equal to 0, we can say therefore x plus 2 is a factor of f of x. Okay, so part A is answered. Part B then, we need to factorize f of x. Okay, but we've already got one factor now, which is ideal. So we can say, look, 6x cubed plus 11x squared minus 4x minus 4. Now remember, if it's a cubic, we're likely to end up with 3 brackets, yeah? Okay, so x plus 2 is our first bracket, and then there's going to be 2 other brackets. Now I don't know what those 2 other brackets are, okay, those will be the other 2 factors, which we need to find, okay? But because there are 2 brackets, don't know what they are, the 2 brackets, when you multiply out the 2 brackets, doing FOIL on 2 brackets, you'll end up with a quadratic, won't you? You'll end up having something x squared, something x, and a constant. Now I know what the x, something x squared is going to be, because it's always going to be what we've got here, yeah? Okay, we need this to be 6x squared, because if you think about it, when you expand this, you got the x times the 6x squared to give me 6x cubed, okay? So that kind of makes sense there that we need the 6 here. Now I don't know what the coefficient in front of the x is, so I'll put bx and plus c there, right? I don't know what the constant is. But what I can do now, I can work out what the b is, what the c is, and then I can factorize it. Now it's better off looking to start with at the constant, okay? So if I look at the constants of both sides, I'm going to sort of equate them. I've got a minus 4 on this side, haven't I? Okay, the constant is minus 4. How do I get a constant here? Well, if you think about it, all it is, you just got to times the 2 by the c, okay? Because that doesn't involve x's. So you've got a 2 here, c here, that makes 2c. Okay, and you can see then what c is going to be. So it's quite simply, you take the 2 over, don't you? And if you take the 2 over, because you're timesing here, when you take it over, you'll end up dividing. So you end up with minus 2. Okay, so that's what your c is. We'll also then look at the x squared term, for instance. So in this here, we've got 11 in front of the x squared. To get x squared from here, now there's 2 ways of getting x squared. Okay, when you expand, there often are a couple of ways of getting it. So in this case here, there are 2 ways, always for x squared. If you think about it, the x, what could I multiply the x by to get x squared? Well, if you think about it, I could, when I do the x times the bx, that will give me bx squared, won't it? Okay, so bx squared, what's in front of the x squared is going to be a b, and then the other way, of course, is multiplying these here, because when I multiply these, I'll get 12x squared, so it'll be plus 12. So So you could see then with that, if 11 is equal to b plus 12, I could take that 12 over the other side and I get minus 1. Okay, so therefore I've got my b, I've got my c. Okay, so my b is minus 1, my c is minus 1x, yeah? So I can just write minus x, and my c is minus 2. Okay, so finally then I need to try and factorize this quadratic here. Okay, so remember when you factorize this, well, there's many ways of doing it. Okay, we often use this way, don't we, where we put 6x in both brackets, and we try and determine then what the two terms are there. Okay, so multiply, add, well, remember they're going to multiply to give minus 12, aren't they? Because you multiply the first there by the last term, so we've got to multiply to give minus 12, add up to give minus 1. So two numbers are multiplied to give minus 12, add up to give minus 1. Well, 4 and 3, don't they? Multiply to give 12, so 4 and 3. Okay, and to add up to minus 1, we need to be minus 4 plus 3, yeah? And don't forget then, you've got to divide by 6, okay? Alright, because of this method. And you can see in the first bracket there's a common factor of 2. In the second bracket there's a common factor of 3. So you've got that there, and that will be your 6, won't it? Because you've got 2 and 3 on the top. 2 times 3 is 6. So you'll cancel that 6 on the bottom. So you end up having x plus 2, 3x minus 2, and 2x plus 1. So you've got to be fully factorized. Part C then, it says find the remainder when it's divided by 2x minus 1. So 2x minus 1, okay. Now we've got to work out what we're going to put into f here, okay. What's going to go in there. Now the good way of doing this is, if you just set that equal to 0, you can then work out what x is going to be. So quite simply, 2x will equal 1, so then x will equal 1 half. That's one really good way of doing it. So we're going to sub in half, right? So f of half, quite simply, put it into your f of x. Okay, so I'll do that on my calculator. And it comes out to be minus 2.5, okay, or minus 5 over 2.